Class we are discussing about the lasers now, so we will continue that topic. Yeah, so in last class we discussed about the different characteristics of the lasers. Okay, these all okay. So now we are going to the some important definitions in laser. Okay, first one is population inversion. Population inversion, so this is the most important one. So if population inversion will be takes place, then only that material will exhibit the lasing action. Okay, so that's why we have to know the what is the population inversion. Okay, so here population inversion is nothing but in a system the number of atoms n1 present in the ground state is larger than the number of atoms present in the higher energy state. Okay, is called as population inversion. So I am saying again here, so this is the first E1 energy state. Here number of atoms are N1. Here E2 energy state. Here number of atoms are N2. Okay, now according to this definition, N2 should be greater than N1. That means number of atoms in a excited state is greater than the number of atoms in a ground state. This is called as population inversion. Okay, so that is population inversion is just simply what is the condition for population inversion means n2 greater than n1. Okay, if number of atoms greater than n1, so number of atoms greater than number of atoms in excited state is greater than the number of atoms in a ground state. That means n2 greater than n1. So this process, this achievement we will call it as population inversion. Population inversion. See here. So condition for population inversion. Okay. So the system should be possess at least pair of energy levels. That means if population inversion occur means here there should be at least two energy levels. At least two energy levels. Okay, so more than two also it's okay. So but minimum at least two energy levels should be there, then only population inversion is possible. Okay, see here, so two pair of energy level, at least two pair of energy level, not two, at least two. So remember here, not two energy levels, at least two energy levels. That means two or more than two. It's enough. Okay. So separated by energy by an energy equal to the energy of photon. Okay, these energy levels are separated by, so whatever we are supplying energy, photon energy, suppose if you want to supply some photon energy, so this energy between E2 and E1 should be equal to the supplied photon energy. Okay, so and next condition, there should be a condition, there should be continuous supply of energy to the system such that the atoms must be raised continuously to the excited state. See here, so suppose what is the lifetime of excited state of electrons? Just 10 to the power of minus 8 seconds. Okay, if you will not supply any energy, suppose if supplied and if you stopped, initially we supplied some energy to the ground state, what happened? All electrons will goes to the excited state. Suppose if you stop the external energy, if you stop the supplying of external energy, what happened? So these excited electrons does not stay much more time in the excited state, so those will comes to the ground state within fraction of seconds. Okay, that's why there is no electrons in excited state. Okay, so here population inversion is not possible. That's why, so what should we have to do? We should supply the energy continuously. We should supply the energy so continuously to the system, then only population inversion is so possible. Okay, here there is a given here, so how to achieve the population inversion? How to achieve the population inversion? So population inversion can be achieved by number of ways. So those are optical pumping, okay, and electrical discharge, inelastic collision of atoms, next chemical reaction, and direct conversion. So these are the different methods to achieve the population inversion. We will discuss these different methods in while we are discussing about the different types of laser. Okay, in different types of lasers, different methods will be used. Okay, so optical pumping is nothing but, so we have to supply continuously to the optical energy to the ground state, that is the optical pumping. Electrical discharge means we have to supply the some potential difference, we have to apply the potential difference of the that material. Okay, so that is the electrical discharge. So in case of gas laser, this electrical discharge we will use. Next, inelastic collision of atoms. Okay, some cases, some gases are also what happen, so collision between the atoms will be takes place if you supply the some external energy, so collision between the atoms will be takes place. So that is the one method. And chemical reactions, so chemical reactions also, if you give some chemical energy, and that means what happened, some atoms will go to the excited state, that is one process. And direct conversion. Okay, so this we will discuss in CO2 laser or any other laser. Okay, so these are the different methods to achieve the population inversion. Okay, now, so first of all, you have to understand what is the population inversion. Just simply N2 greater than N1. What is the N2? Number of atoms in a excited state. Okay, what is the N1? So number of atoms in a ground state. So N2 should be greater than N1. Okay, that is the population inversion. So what is the condition for population inversion means? Here there are two conditions are there. First condition is E2 greater than E1. What is the E2? You know that. So E2 is the energy of this level. E1 is the energy of this level. Okay, so what is this level? Excited energy state. So this is the ground energy state. Okay, now, so second condition, we have to supply energy continuously. Okay, so this is about the population inversion. Now coming to the metastable state. So metastable state we will discuss it here. So this is the normal states. So this is a ground state and this is a first excited state. Okay, so so this is the normal population inversion. So this is the normal state here. So in that normal state, to achieve the population inversion is very difficult. Normal state, that means if you will take like only two level laser system, to achieving the population inversion is very difficult. Because, so here if you observe in an excited state, what is the lifetime of electron? Only just 10 to the power of -8 seconds. Okay, so that's why what happened, so automatically after 10 to the power of -8 seconds, that means within the fraction of seconds, automatically that electron will goes to the ground state. That's why, so that electron will not stay much more time here. Okay, so for getting the population inversion here, we have to supply more amount of energy. We have to supply the, so and that energy continuously, and so huge amount of energy. Okay, for reducing this problem, for getting this solution of two level laser system, so what we are doing, so we are using another level system, that is the metastable state. First of all, what is the definition of metastable state? Metastable state is an excited state. So this also an excited state of an atom, and this state have longer lifetime than other excited states. Okay, so see here, so metastable state also one excited state, but it should have longer lifetime than other excited states. Okay, see here, see this diagram. Here three levels are there. So first level is ground state. So these two are the excited states. So this lifetime, see here, so this lifetime is here 10 to the power of -7 seconds. But here, so this lifetime is -10 to the power of -3 seconds. 10 to the power of -3 seconds. That means this lifetime is greater than the, so this lifetime. So that's why, so this state we will call it as metastable state. Understood? So here energy, so lifetime of the state is greater than the, so remaining excited states. excited state. So however it will be there, suppose 4 states will be there here. So among the 4 states, this energy state lifetime is more. So that at the time we will call it as this is the metastable state. Okay, just definition is lifetime of the excited state is greater than the remaining excited states is called as metastable state. Metastable state. So at this situation what happened? So electrons will stay more time here. Electrons will stay more time here. That's why we'll get population inversion very easily. We'll get population inversion very easily because so here lifetime of the electron is greater than the so other excited states. So here 10 to the power of -7, here 10 to the power of -3. That's why here lifetime is greater. So here this state will act as a metastable state and population inversion will get very easily. Okay, this is about the metastable state. Now lasing action. How lasing action will be takes place? So what are the steps involved in a lasing action? Okay, so here majorly 3 steps are involved. So 3 steps are involved. First step is pumping. Second step is population inversion. Third step is stimulated emission of radiation. Okay, so pumping. What is the pumping? Why this pumping is needed? To achieving the population inversion. To achieving the population inversion, we have to supply energy continuously. We have to supply energy continuously. So if you supply energy continuously to the ground state, what happened? Those electrons will goes to the excited state. This process we will call it as pumping. If you supply energy continuously to the ground state, what happened? So the ground state electrons will move to the excited state. This process we will call it as pumping. Yeah, see here definition, exact definition. The process of sending atoms from lower energy state to higher energy state is called as pumping. Okay, so this process of sending the either electrons or atoms so to ground state to higher energy state, this process we will call it as so pumping. There are different pumping mechanisms are there. Above we discussed now. So above we discussed different pumping mechanisms. See here. So these are the different pumping mechanisms: optical pumping, electrical pumping. Okay, so inelastic collision pumping, chemical pumping, and so direct conversion pumping. So these are the different types of pumpings here. Okay, different pumping mechanisms are adapted depend on the type of laser. So which type of laser? So that depends on the type of laser. So we are taking different types of mechanisms. See here. Here examples also given for ruby laser and ND-AG laser. So these are the solid state lasers, ruby laser and ND-AG laser. Okay, so these are the solid state laser. In these solid state laser, we will use optical pumping mechanism. Okay, so for helium neon laser, the pumping mechanism is electrical discharge. Okay, and CO2 laser, the mechanism is chemical reaction. Okay, so these are the some examples for which type of pumping we are using. Okay, so in case of ruby and ND laser, we'll use optical pumping mechanism. For helium neon laser, we'll use electrical discharge mechanism, and CO2 laser will use chemical reaction mechanism. Okay, so these are the different pumping methods. Now, so population inversion. So what are the requirements? What are the major steps? Means first pumping is required. So second one is the population inversion is required. Okay, population inversion can be achieved with the presence of metastable state. Okay, so for 2 states also we will get the population inversion, but that is very difficult. Okay, if metastable state will be there, means it is very easy to getting the population inversion. Okay, what is the population inversion? Number of electrons in a excited state is greater than the number of electrons in a ground state. That condition we will call it as population inversion. Okay, next one is the So stimulated emission of radiation, this also important one here for getting the lasing action. So stimulated emission also so important. So photons produced by stimulated emission are in phase and they produce coherent light because of the stimulated emission. So what we are achieving, we will get the so those all photons are in phase, and so those all are in coherent, those all are in coherent. Okay, so this is the population inversion, population the stimulated emission of radiation. Because of stimulated emission of radiation only, what happened here, we will get in the so all are in phase, all emitted photons are in phase. So because of that in phase, what happened, that light is coherent light, that emitted light is coherent light. Okay, now laser system, if you will take laser system, so that consists of these basic parts. So what is the laser system consists means, so here, so first one is the active medium, active medium. So this is the active medium here. Okay, that medium we will also call it as laser medium. And second one is energy source. So energy source means pumping mechanism, what type of pumping, source for pumping. Okay, and so optical cavity, optical cavity we can also call it as resonator, we can also call it as resonator. Okay, so these three basic parts are major. So for to prepare the laser system, so these three basic parts. So first one is the active medium. What is that active medium means? So with the suitable set of energy level to support the laser action. Okay, suppose here if you will take ruby laser, in that ruby laser aluminum and chromium, Al2 alumina, Al2O3 and so chromium both will be there. In that active medium is chromium 3 plus ions. Chromium 3 plus ions are the so active medium, because so these Cr3 plus ion energy levels support to the so sub see here, so energy levels, suitable set of energy level to support the laser action. So here Cr3 plus and to support the so laser action, so those energy levels to support the laser action. So that's why here Cr3 plus is the active medium. So in which medium, in which medium so lasing action is possible, that medium we will call it as active medium, active medium. Okay, now energy source. So energy source, in order to establish the population inversion, we need some energy source, we need some energy source to getting the population inversion. Okay, so that is the so either electrical pumping, optical pumping, so optical energy stores, electrical energy stores, whatever the energy source here, it will be there. So energy source are must required to get the pumping, that means to achieve the population inversion. Okay, now next one is the optical cavity, this is most important one. So optical cavity, okay, so our resonator to introduce the optical feedback and maintain the gain of system, overcoming all losses. Depending on the type of system, optical feedback is provided with the help of uh, dielectric mirrors or polished and coated ends of crystal rod or cleaved crystal surface. Okay, here so these are the optical cavity, this one is the optical cavity. So inside the optical cavity total laser system will be fixed. Okay, so this optical cavity will be prepared by using, so if you will take mirrors, so here so one side 100% reflecting mirror, another side only it will reflect 95%, it will reflect only 5%, it will transmit. Okay, so instead of these mirrors, we will use what is that, polished surface also. So polished surface dielectric materials also will used. Okay, so instead of mirrors, that polished surface also so will reflect back whatever instant the laser on it. Okay, so this is the optical cavity here. Now, so here different levels will be there, 3-level laser system and 4-level laser system. So why we are taking here different level laser systems means, so to getting the population inversion, see here, suppose here this is the 3-level laser system, E1, E2, E3. So their energy states. So E3 energy is greater than the E2 energy. So E2 energy is greater than the E1 energy. E3 greater than E2 greater than E1. Okay. So like that, similarly, so number of electrons here. So here lifetime. So first of all, that number of electrons is depends on the lifetime of the state. Okay, E3 having very less lifetime compared to E2. Okay, that's why here in case number of electrons in E2 levels are greater than to the E3. So that's why, so population inversion occur between the E2 and E1 levels. E2 and E1 levels. See here. So population inversion is takes place E2 and E1 level. Okay, because of this population inversion, what happened here? Stimulated emission is possible. Okay, so this is not much more important, that three level laser system, just for your idea. Okay, so based on diagram you can write. Okay, now 4-level laser system. Here 4 energy level states are there. 4 energy level states are there. See here. So this is the E4 energy is greater than E3 and E3 energy is greater than E2. E2 energy is greater than E1. Here E1 is the ground state. Remaining all are the excited states. Here population inversion will be takes place in between the E3 and E2 level. Okay, E3 lifetime is very greater. Yes, E3 lifetime is so very greater than the remaining other lifetimes, remaining other excited lifetimes. So that's why here E3 level will act as a metastable state according to our definition. What is the definition of metastable state? In which state lifetime is greater than the remaining excited states. Okay, here E3 energy state lifetime is greater than the remaining excited states. That's why population inversion occur in between the E3 and E2 levels. Okay, so because of achieving of this population inversion, what happened? Lasing action will be takes place in between the E3 and E2 levels. Okay. Yeah. So here pumping and pumping methods. So we are discussing about the different pumping mechanisms. First one is the optical pumping, electrical discharge, chemical reaction, thermal pumping. So first of all, what is the pumping? A system in which population inversion is achieved is called as active system. Okay, first of all, what is the active system? Means a system in which population inversion is achieved. Okay, so otherwise in a system in which lasing action takes place, so that is called as active system or active medium. Understood? A system in which a population inversion is achieved, so is called as an active system. So otherwise, one more definition, a system in which lasing action takes place, okay, is called as an active medium. Okay, and so the method of raising the particles from lower energy state to higher energy state is called pumping. Okay, so here pumping, what is the definition of pumping means? So the method of raising the particles from lower energy state to higher energy state is called as pumping. The method of raising the, so here we can call it as particles or electrons or atoms. Okay, so the method of raising the atoms from lower energy state to higher energy state is called as pumping. Okay, so that is the definition of pumping. There are different methods of pumping. Okay, the energy to create the population inversion. What are those pumping? Optical pumping, electrical discharge, chemical reaction, thermal pumping. So what is the optical pumping? In this method, light is used to supply the energy to the laser medium. Okay, so here we will supply the light energy. In case of optical pumping, we will supply the light energy to get the population inversion. Okay, so here, so what is the material we have to use to get the so light optical energy source? Okay, so here, so to light source, so xenon flash lamp we will use. Xenon flash lamp will use to so supply the what is that optical pumping. So optical energy, to supply the optical energy will use xenon flash lamp. Okay, and the next electrical discharge. In this method, the pumping, so the pumping is electrical due to electrical discharge. So act as the pump source or energy source. Okay, so a high voltage electric discharge, that means electric discharge is nothing but flow of electrons or electric charge, flow of electric charge or electric current, flow of electric current. So due to these reasons we will get the electrical discharge is passed through the laser medium or gas. The method of pumping is used in a gas lasers such as argon lasers. Okay, so in case of gas lasers, so helium neon laser, we will take helium neon laser. We will use electrical discharge to get the population inversion, to send the electrons from lower energy state to higher energy state. Okay, next chemical reaction. So in that chemical reaction, in an atom or molecule is produced through some chemical reaction and remains an excited state at the time of population inversion. Because of the chemical reaction, so those atoms will goes to the excited state, then we will get the population inversion. This pumping mechanism we will call it as chemical reaction. So next one is the thermal pumping. So we will supply the thermal energy or heat energy to get the population inversion. That is the thermal pumping. Okay, so types of lasers. Here, so many types of lasers are there, but mainly we are discussing in this topic is so solid state laser, gas lasers, and semiconductor lasers. Okay, so many types of lasers are there. So we are discussing mainly here solid state laser, gas laser, and semiconducting lasers. So examples for solid state lasers are ruby laser and YAG lasers. Okay, gas lasers. So gas lasers examples helium neon lasers and CO2 laser, and semiconducting lasers. Semiconducting lasers example I will tell you in the class. Okay, first one is ruby laser. Okay, so first one is the ruby laser. So generally, so just simply we will discuss about the ruby laser. Okay, ruby laser is the first type of laser demonstrated in the year of 1960 by Th uh, Mamin. Th Miamin. Okay, so this is the first laser. Ruby laser is the first laser. So this was prepared in 1960. So this is the solid state laser. Solid state laser, and it is a 3-level laser system. So see here. So this is a 3-level laser system. Okay. So and active medium. So the active medium in ruby rod is so Cr3 plus ions. Cr3 plus ions are the active medium. Okay, this ruby rod is prepared by using alumina. Alumina means Al2O3 plus chromium oxide Cr2O3. Okay, so this is the this rod is ruby laser is combination of alumina and so chromium oxide. Okay, so Al2O3 plus Cr2O3. Here Cr3 plus ions will act as a active medium. That means those are involved in a lasing action. Those energy levels are involved in a lasing action. See here, lasing action takes place in chromium energy levels. Okay, what is the energy source? What is the energy source? The pumping of ions is through optical pumping. Optical pumping means so how to produce the optical, how to supply the optical energy here by using xenon flash lamp. By using xenon flash lamp. 1 minute.
హార్డ్ కాపీ మీ మెయిల్ సెండ్ చేయాలా
మా నా మెయిల్ సెండ్ చేయండి. హార్డ్ కాపీ కింద మీనాక్షి మేడం
నేను
I will send you. Okay, so we'll get the population inversion. So by using here, so optical pumping, how to supply the optical energy. So by using, so which energy we have to use means optical energy. How to supply optical energy means by using xenon flash lamp. By using xenon flash lamp. Okay, see here. So this is the 3-level laser system. So Ruby laser is 3-level laser system. So this is the first excited state, that means second energy level. So this is the second energy state, that means second excited state, that means third energy level. Third energy level. First energy level is ground state. Okay, so this second energy level is act as a metastable state here. Metastable state. Yeah. So construction of Ruby laser. Ruby is basically Al2O3 crystal, contains 0.05% of chromium atoms. Okay, so how much we are doping? So maximum we are doping ruby rod. So in that ruby rod, so that is the alumina rod only. Just we will dope the chromium atoms, chromium atoms Cr2O3. So we will dope just 0.05%. 0.05% chromium atoms will dope. Okay, here Cr3 plus atoms are the active centers. So these are the here Cr3 plus ions are the active centers. So while Al and oxygen atoms are inert. Aluminum and so oxygen atoms are inert. So chromium ions have absorption bands in the blue and green regions. Okay, so those chromium energy bonds, the chromium energy bonds having particular energy gap, those energy levels having particular energy gap will send the blue and so if because of this ruby rod what happened, so blue and green energy, so energy will be emitted, so blue and green radiation will be emitted. Okay, now ruby rod is taken in the form of cylindrical rod of about 4 centimeter in length and 1 centimeter in diameter. Okay, ruby rod is taken in the form of a cylindrical rod of 4 centimeter in length and 1 centimeter in diameter. Okay, 1 centimeter in diameter. Just remember here. So this is the cylindrical rod. Length is 4 centimeter and diameter is 1 centimeter. Its ends are grounded and polished. Okay, so that these are the ruby rod here. So this ends, so this is one more end, this is another end. So these are the polished ends. These are the polished ends. So one end is so fully reflected. Another end is partially reflected. That means here 95% it will be reflect back, only 5% it will be transmit. It will be transmit the light. The end faces of ruby rod are silvered. The end faces of, so already it is polished and so silvered also. So that polished surface is silvered. So silvered means it will, light is not emitting out. Light is not emitting if you so make the silver coating. If you make the silver coating means that light is not emitted out from the that so ends. Okay, suppose if you will take mirror, normal mirror. So if you will take normal mirror means that is a transparent mirror. So it will, so if you will take normal glass, it will transmit from one end to another end. So one side will be coated with silver. So what happened? So our image will be appear on that mirror. That means it will be not transmitted, only it will be reflecting back. So totally it will be reflecting back. Okay, that's why one face is so fully silverly coated, another face is partially silver coated, another face is so partially silver coated. Okay, so that's why it will be act as a optical resonator. So these will act as a, these edges will act as a so what happened, optical resonator means so one phase, rear phase means backside face will act as a fully reflecting. So while front face will act as a partially reflecting. Partially reflecting means 95% reflect back, only 5% transmitted. The razor rod is end. So this is the rod, ruby rod. This ruby rod we will also call it as laser rod here. So those laser rod is surrounded by a helical photographic flash lamp. Okay, photographic flash lamp filled with xenon gas. Filled with xenon gas. Okay, whenever activated by the power supply that the lamp produces the flashes of white light. See here. So here electrical power supply. Electrical power supply is given. So if electrical power supply is given means what happened? So that xenon inside this what is that? Helical photographic uh, flash lamp. This is okay. So in that helical shape, inside helical tube, inside xenon gas will be there. Xenon gas will be there. Whenever we will supply the uh, electric field here, electric field or voltage here, what happen? That gas will goes to the excited state. That gas will goes to the excited. That means xenon it will be generally it will be available in xenon form. It will goes to the excited state means it will be so xenon xe plus. Okay, so it will goes to the excited state. It will not stay much more time in the excited state. It will comes to the ground state. So while it is coming to the ground state, what happened? So photon will be emitted. That emitted photon will touches to the ruby rod. That emitted photon will touches to the ruby rod. That means optical energy supplies to the ruby rod here. Okay, so because of this xenon flash lamp, so that optical energy supplies to the this ruby rod. Optical energy supplies to the ruby rod. Okay, now working. How much time is there? Yeah, so we'll discuss this working next class. So this is about the ruby rod, ruby laser. Okay, so this is the ruby laser here. This is the construction of ruby laser. So if they ask ruby laser means you have to write the just what is the active medium, what is the energy source. Okay, so and what type of laser it is, 3-level laser or 4-level laser, and construction. So in that construction we have to discuss what is the material we are using. So what is the active medium above we discussed. So how much? So Al2O3 and chromium we are using. So how much percentage we are doping here, we have to discuss. So what is the energy source? We have to discuss here. So that is the construction. Tomorrow we will discuss about the working. Okay, I will take the attendance. Yeah, so if you have any doubts you can ask, otherwise you can leave from the session. Yes, any doubts? If any doubts you can ask, otherwise you can leave from the session.